Normalization is the process of adjusting the amplitude of an audio signal so that its peak level reaches a specified target level. In layman's terms, it raises or lowers the entire waveform proportionally so that the loudest part reaches a desired level. In other words, the same gain adjustment is applied to the entire clip, whether that makes the clip louder or quieter.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.
Types of normalization. Manual gain editing. Select an area on the waveform. This can be the loudest or the quietest part that needs adjustment. Use the floating decibel gain adjustment panel to increase or decrease the gain of that selected section. This reduces or increases that section's amplitude without affecting the rest of the clip. This approach is commonly used to tame sudden peaks, balance dialogue levels, and fix uneven recordings. While most of these issues can also be addressed by using compression, manual gain editing is often faster and more precise when the problem occurs only in a few areas of the recording. By lowering a specific loud section, we are effectively creating headroom before normalization. For example, if there is an unnecessary spike in the waveform, such as a cough, we can reduce that section manually before normalization. This allows the overall waveform to be closer to the correct baseline before even applying automated processes. Normalize Effect. There are two ways to apply the Normalize Effect. First, go to Effects, then Amplitude and Compression, then Normalize Process. Instead of using percentages, we are going to be using decibel levels for precise controls. -3 for the common editing level, or -1 for broadcast level.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.
Second, go to Favorites, then Normalize to -3. There is also an option for Normalize to -0.1. The goal is not to reach 0 decibel levels, because once we hit 0 decibel levels, our audio will clip or will be distorted.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.
Key limitations. While normalization can prevent clipping, normalization cannot repair distortion that already occurred. For example, a microphone clips during recording. Normalization can prevent clipping from exceeding a target peak level, but it cannot restore audio that was already clipped during the recording. It is already embedded in the waveform. Normalization does not analyze context. It only finds the loudest part of the waveform or the peak and apply gain change to the entire waveform. It does not consider dialogue from a cough, dialogue from noise, and consistency. For example, if your audio's peak is 0, a cough, and you normalized it to -3, which is the most common target level, it will reduce the entire clip's amplitude by -3, even the quieter parts.